Hello viewers, welcome to my channel Connect Civilians. So here we will design the uniform eccentric rectangular footing with uniaxial movement mx or my. Okay, so we have already done the manual calculation for this. If you haven't checked that video, you can go and check. I will provide the link at the end of the video. Okay, and here by using this Excel sheet we are going to design the our eccentric rectangular footing with uniaxial movement. So this will be your load value that you have to mention. So what value you have to initially give, I will just show you. So we have just cross verified with our manual calculation. You can just put all the value according to that, and you can also verify the calculation whether it was wrong or right in manual or in Excel sheet only. Okay, so here it is 550 we are going to consider. So this dark green, in dark green box you have to give the values by yourself, and all the other value will be calculated by the Excel sheet only. Okay, so first you have to mention your load that is coming from the column. So you can get the result from your software also, from STAD or ETAD, and you can find the load from there also for the design. Or you can just, if you don't have much more data for the foundation design, so you can just give the value according to your experience or according to your floor, and just check whether your footing will be safe or not. Okay, so here we are going to consider by giving the service load, that is P is equal to 550 kilonewton. So your P factor will be calculated as 825 by itself. SBC is taken as 250 kilonewton. Column size will be, so you have to give the longer value, longer side of the column and shorter side of the column in these boxes. So our longer side is 430. This will be the rectangular column design, and this shorter side will be 230 mm. Okay, unit of the weight of the soil will also given here, that is 16 kilonewton per meter square cube. Sorry, depth of the footing we are considering as 1.5. So you can just find the gross soil pressure from these values. And grade of the concrete for footing is 25, and grade of steel is 415. Self weight of the soil will be 24. So this value will be calculated. So I'm going to just change the color of this box, because it is going to calculate by itself by the formula. Okay, self weight of the percentage of the footing you have to give. Okay, so here we are considering 12%. Okay, now grade of the concrete is for column is 20 Newton per mm square. So now these value will be calculated here, and if you have also the moment, so this will be for the moment. So here it is for uniaxial moment. So for mx, so if you are the value for the moment in x direction, so you have to use this Excel sheet, and if you have moment for y direction, you have to use this Excel sheet. So I provide both the Excel sheet together. You can just download and check from there. Okay, so first we are going to, for if we have the value for mx only. Okay, so here I have ultimate moment value. If you don't, so you have to give the value in for mx here, so it will be calculated by itself. Assume it is 150, so my value is for mx is 150, and so here what will happen, you have to multiply it by 150 into 1.5. This will be your ultimate. Okay, so this will be calculated by itself. Okay, maximum time you don't have ultimate value. Okay, so whatever value you have present, so you have to just fill according to you. So this will be the mx value we have given, that is 150, and our ultimate mx value will be calculated as 225. eccentricity is also been shown here, that is coming as 273. So our center of footing and center of column will be 273 mm away from each other. Okay, now all the value is shown here. So these value will be calculated by itself. Now all the manual calculation value will be given, and here it is that calculate the section modulus, and it will be calculated. All you need to do is to see either these boxes will showing you okay or not. So this will be showing you okay and this will be okay. So according to this you have to just check what length and width of the footing is shown here. According to that you have to provide, so provide the larger value. If it is showing 1.65, you have to go for the larger value. Okay, if it is showing 1.45, you can also go with 2 and 2.5. okay, what will the length and width I will show here. So length will be showing in x direction, that this, and it will be showing in y direction, that will be this. Okay, so I'm considering the value as 2.5 and 2. Okay, so this will be the size of the footing and it will also showing you okay. So this will be safe till now for the design. Let's decrease this value. Okay, so see, all the value will change and it will also showing you here not okay, it will also showing you not okay, not safe. So you have to increase the value directly just, and it will be showing you okay and it is safe for the design. Okay, now you can go for bending moment if you want to check. So this value will be calculated by itself. If you want to just calculate the net upper pressure by yourself, so you can use the interpolation sheet and fill the values for manual calculation also. Okay, this will be your p minimum, this will be your p maximum. So this values and this will be a distance at the zero position and at the end position. Okay, I have already shown in manual calculation. Okay, so you don't need to do or make any changes here. Just go down. So depth of the footing will be calculated from there here only. See, and if we are using Fe415, so this formula will be calculated by the 0.138. Now it is showing you 0.138 FCKBD square. So let's assume we have changed the value as 500. Okay, the grade of steel is 500 right now. So see, 0.133, so it will automatically change according to the grade that you have given. Okay, for now I am going with Fe415 only. So it is showing you 0.138. Your dx, then effective depth will be calculated for both the direction, that is x and y. Now according to this you have to fill or give the total depth of the footing, cover that you want to provide, and the dia of the bar. For the bar, for the first that is layer, that is for x direction layer, and for the second layer that is for y direction. This orange bar is for x direction and this green bar will be for y direction bar. Okay, so generally I will guide you how to provide the depth. What you have to do, if you see the effective depth is calculated at 194, so go with the double of these values, so that will be more safe for one way and two way also. Okay, so if you just increase the overall effective depth as double, it is coming 194, so take the overall depth of 5 as same, that your effective depth will come around more than 300. Okay, so that will be more safe for one way and two way checks. Okay, so that's why I am going with the higher value for 500. You can also go for 400 and check after that whether it is passing or not. Okay, so you can go with according to your requirement also. Okay, so I'm going with the overall depth of the footing is 500, cover I am taking as 50, by order for bottom layer as 12 mm, and for the second layer also as 12 mm. Now our dx effective depth for both directions is calculated here, and this will be safe till now for the design. So we will go further. All you need to do, you have to change this green boxes and you have to see whether it was safe or not. Okay, reinforcement is calculated here, minimum value we calculated. This will be showing you 15 number of bar required. So here we have given 18 number of bars. Okay, just go with 16. Let's check. 16 is also okay, but here we are going according to our check. We have already done the checks. If we go with 16 number of bars, here it is safe, no problem. What will happen? Okay, 18 number of bar. I'm going with 18 number of bar here. So we will done according to our requirement, as we have already done for one way check, and from how we have done for one way check from this table. Always remember this table. You have to use the this table for one way check, table 19. Okay, so that's why we have taken more number of bars. Okay, as it was going to fail for one in one way. We have already done that. That's why we are taking more value. You can go with 16 number of bar. Okay, if you want to. Here it is showing you okay, that will be safe, no problem. Here it is showing you okay in all the boxes. Okay, go with the minimum here for y, and according to this you can check, but I'm going with 18 number of bar only, and we will see what will be the design. Here it is okay, and our center to center spacing is also showing you okay. Now it is safe for x. Now you'll see for y direction. Here it is showing you that go with the minimum. So what is this? Because our AST required is calculated 1053 and our minimum is calculated 1500. So that's why it is showing you take the minimum reinforcement. Okay, and go with the minimum. So if you go with 30 number of bar, it will show you not okay. If you go with 40 number of bar, it will show you okay, because our area is coming at 1583, that is more than our 1500. That is what minimum AST minimum is coming. That's why it is showing you okay, but we are going with larger value, as we have already told you for one way and two way checks. Okay, spacing will be okay, center spacing will be okay, so showing you okay, that will be safe. Our central bandwidth reinforcement, so we have not done in manual calculation for the central band, as we have already done for the rectangular footing. Okay, for uniform thickness. So you can go and check from there the central bandwidth calculation reinforcement, and here it is also done. So now spacing will be required with 113, so you have to provide the spacing according to you, whatever value you have to want. Okay, but you don't have to provide more than 113. So I am okay with 110, and here I am providing. So you can't provide more than 180 also, because of our steel grade that we have taken. That's why it is showing you provide less than 180. Okay, so this value will be changes according to your grade that you have given. Always remember this. So spacing required is 900, so we can't go with more than 180, so I'm going with 150, or you can go with 180. So this central bandwidth reinforcement will be okay or safe when you provide your dimension of footing is much more in rectangular shape. Okay, here we are providing 2 into 2.5, that is area of the footing. So if you don't go with central bandwidth reinforcement method, that will be okay. But example, if you are providing the one length of the footing as 2 meter and the second length of footing as 4 meter, so this will be your 2 meter difference in the area of the footing, sorry, in the side of the footing. So you can go with this method. Okay, in central bandwidth the reinforcement is provided according to this spacing. Okay, now the one way shear check for both the x and y direction. So here I've already shown you both for both the direction, that is for x also, for y also. That was not necessary, because if once you calculate for the longer direction, the shorter direction will be safe automatically. But here we have shown you, and this table, see table 19, Here you have to provide the value according to the percentage of steel and according to the grade of the concrete that you have taken, okay, from table 19 from I score 456. So this check will be taken according to this. So our percentage is coming 0.229. Okay, see here it is interpolation table I will show 0.229. Provide the value at the center, and 0.229 here in table 90 it is coming in between 0.15 and 0.25. Okay, so I will write 0.15 here and 0.25 here, and our grade of concrete is M25. So M25 our value is coming 0.29, 0.36 from the table. So here you write 0.29 at the top and at the bottom 0.36. So our value will come as 0.345. So this will be a tau c dash value 0.345 you have to provide here. Okay, now it will showing you safe here, that will be safe. That's why I'm not providing lesser still, because we have already checked for that. If you provided the lesser still number of bars, okay, so this will be decreased and this value will be nominal shear value will be more, that will not save. Here it will show you not save, that will not correct. Okay, so all you need to do, just you have to take the help of the IS code, and from this table by the interpolation you have to fill this value, and you have to see whether it is safe or not for X and Y. So you have to just see the percentage steel and grade of the concrete for this value and just see whether it is safe or not. Now here it is safe, that will be fine for we are going with two-way check. So in two-way check you don't have to do anything, all you need to do is to just see here either it is safe or not. This will be simple. Okay, we have already done in manual calculation, you can go and check the manual calculation, and here you have to just see whether it is safe or not. If it is not safe, you have to increase the depth on the footing or size of the footing. Okay, and here it is also showing you transfer of load at the base. Okay, it will show you IS code 456 page 65. You can check from there how formula is calculated, how area is calculated. Okay, see here it is showing you not sure dowel bar required, not sure dowel bar required. So extra load will be here, dowel bar needed. So if it is not needed, so right now it is needed. Okay, dowel bar needed, so you have to provide a diagonal wall here. Okay, so here we have provided 25 mm, so number of dowel bar required as 20 mm. If you put a 12 mm bar, 87 bar required. But if you put a higher diagonal bar, so it will be required as 20 number of diagonal bar. 20 number bar will be required, and final weight of footing will be calculated as 62.5 Newton. That will be also safe. Okay, so this will be depend on your self weight that we have considered. That is, if you consider 10% at starting, so that will not be safe. Here we have considered 12%. Now it is safe, but if you consider 10%, I will show you at the increase the self weight of the footing. It will show you. So this will not be safe. You have to increase self weight of footing at starting only. So that's why we are considering 12% at the starting of the design. Okay, you have to check this. Here now it is safe. Okay, so assume this value will coming as more than this 40.9. Assume this value coming as 50, and this value will also come as 50. See, so this value will be more than 40.9. No dowel bar needed, no extra dowel bar needed, no dowel bar needed. So you don't have to provide any dowel bar. Simple. You don't have to provide any dowel bar. Okay, but by this calculation it is needed, so you have to provide a dowel bar. So where it is provided, how it is show, I will show you in the figure. So this L shape, so this will be your dowel bar, so you have to provide here. Okay, and you have to lap in column and provide according to the development length. Okay, this is how your development length is calculated. So what diode bar is coming from the column, you have to provide the bar here, and you have to check what bond stage is coming according to the grade of the concrete. okay. And we have to also see what type of bar you are using. So if we are using the HIT bar, so we have increased by 60%, okay. So our LD will become a 645 mm and our available length is 816 mm, so this will be safe. So you have to provide a development at 655 mm here, okay. You have to increase this at here, okay. So this will be your dia bar and this will be the orange layer, the first layer. You have to put 12 at the rate of 101 center to center. Similarly, second layer bar will be as 12 at the rate of 126 center to center. And if you are using the central bandwidth calculation, what you have to do, you have to just change the bar of the second layer, that is in of green layer, okay. So this black area, that is 2 meter of width. So what you have to do, this will be 2 meter, so this will be 2500, so up to 2 meter from this side also, from center you have to provide the bar at 12 at the rate of 110 center to center, and after that on both the edge of the corners of the footing you have to provide 12 at the rate of 180 center to center, okay. So if you are going with this, that will be also okay, that will not be problem, because the area or side of the footing will not be greater than 2 meter, that is 2 meter is here and 2.5 meter is here, so there will not a much more difference in the size of the footing, so that will be okay. But if you are going with 2 meter here and 4 meter here, so you have to follow the central bandwidth meter and you have to follow this reinforcement, okay. So you have to provide the central ring according to the this, that is 12 at the rate of 110 central center, and at the corner, that is after 2 meter, you have to provide the 12 of 180 central center in second layer, that is in green bars, the bar that is bar parallel to y direction, okay. So by this figure you can easily provide the bar and you can easily check the dimension of the footing from here, okay. So I hope if you have liked this video, and for my also it is also given here, so I will provide both the Excel sheet together. You can download it and design your uniaxial rectangular footing, eccentric footing without any problem, okay. So if you like this video, please subscribe to my channel. Thank you.